This video and the next one dive into some deeper details as opposed to the previous videos. And they are a little longer in time than most of the videos in this course. However, they are quite important to understand how to work with MOVEit. So please pay good attention. Maybe you could also take a short break and come back, okay? All right. The MOVEit Setup Assistant just created a new ROS package for us. And here, we are with a whole bunch of configuration files. Well, first things first, after we create a new package, we build it so that our setup files can update their ROS package list, and then we source our updated setup files. Now, we can navigate to the hrwros_moveit_config package with roscd. Okay, as you can see, there is a package.xml file, and let's see what's in there. As per our configuration, we have the author details, and a set of dependencies for this ROS package. Now, let's dive right into the package. We see our other packages as well here. In the MOVEit config package, we have two folders, config and launch. We learned in week 1 that whenever we are given a new ROS package and want to know how it works, the launch files give a nice overview of which ROS nodes will eventually be running. So let's begin with the all-important move_group.launch file. As you can see, this launch file seems to be doing a lot of things. Okay, let's go in order and look at the planning_context.launch file. As the name suggests, this file sets up the context in which we will be using MOVEit for planning. So, at first, we make sure we have the robot_description parameter available on the parameter server. And since this parameter is usually loaded by another launch file, the default value to decide whether or not to load this parameter here is false. But if you did not do this elsewhere, you can set it to true, and it will load the robot.urdf file as the robot_description parameter. Next, we have the robot_description_semantic parameter, loaded from the SRDF or the semantic robot description format file. And this file is located in the config folder. So let's go there and open it. Here, we can see the semantic information, such as the two robot groups we defined, also, we have the robot configuration or robot poses we defined as R1 up and R2 up listed here under the group_state tag. Then we have our virtual joints, and lastly, the entire list of link pairs for which the self-collision checking step decided that there is no need to check for collisions because there is no chance that these link pairs would collide. And remember, when we update the URDF file with new collision geometries, we will have to run the setup assistant again to redo the self-collision checking. Okay, next, let's look at the joint_limits.yaml file in the config folder. As the name suggests, joint-specific limits for each of our robot arms are automatically updated here from the URDF files of the robots. Then, the last file in the planning_context.launch file, which is the kinematics.yaml file. And here, we have the specifications of the plugin or library we will use to do kinematic computations. As you can see, the TrackIK plugin we configured in the setup assistant is updated here. All right, so that's our planning context. Here are two groups of settings related to code debugging settings and logging settings, which we can skip for this course and leave them untouched. Then, we have a few parameters here for the move group node. The first two we will investigate soon. The next two parameters are not necessary for this course as they are associated with advanced MOVEit capabilities such as replanning an alternate path by integrating sensory information. And then the published_monitored_planning_scene is a parameter used by a submodule of MOVEit called the planning scene monitor, which we will also not cover in this course. So let's leave it in its default setting. Okay, let's now move on to the next config file, planning_pipeline.launch.xml. Here, we see that the OMPL planning pipeline is used, and so let's then go to the OMPL_planning_pipeline.launch.xml file. Here, we see a lot of internal settings for using the OMPL planning library, and in the OMPL_planning.yaml file, we see a whole list of planners available to use for planning. And here, we also see the RRT Connect planner listed, which we configured as the default planner for our planning groups in the setup assistant. Good. So we now know what our planning context is and what planning library MoveIt will use. Let's now see the configurations for trajectory execution. And we saw earlier that we allow MoveIt to take care of trajectory execution. So let's look into the trajectory_execution.launch.xml file. All right, so if MoveIt has to take care of trajectory execution, it will have to manage some controllers or communicate with controllers that can actually execute a trajectory on the robot arms. And that's the purpose of the MoveIt_manage_controllers parameter. The rest of the parameters here are related to trajectory execution tolerances, and their details are beyond the scope of this course. But let's definitely look at the controller manager settings to understand how MoveIt manages trajectory execution. And the argument here is hrwros. So the correct controller manager file is hrwros_moveit_controller_manager.launch.xml. Let's see what's in it. Oh, this is empty. That seems to be a little different than what we are used to seeing so far, with everything being done for us. How do we find out what to fill in here? Let's find out in the next video.